So here we go. What I want to show you guys how to do is graph the cosecant of pi x. So one thing, guys, when we're getting into cosecant and secant functions, we have to remember how cosecant and secant relate to one another. So remember, this cosecant is the reciprocal of the sine function. That means I could typically really write this as 1 over the sine of pi x. All right, it's the reciprocal. They're reciprocals of one another. We talked about this when we were talking about reciprocal identities. We showed you guys how this property works. So what we're going to do is we know how to graph the sine of x. Or at least we know how to find all the important parts to graph the sine of x. So what we're going to do to graph the cosecant is we're going to use the sine graph to help us graph it. All right? So let's kind of focus our attention right now on just graphing. How would you graph the sine of pi x? Well, remember, we go through kind of some certain important points, right? The first thing we try to determine is the amplitude. Amplitude is the absolute value of a, which in this case is 1. So our amplitude is equal to 1. That's going to be the max. That's going to be half the distance between the max and the min on the graph. Then we take a look at the period. Remember, the period goes by a function of 2 pi divided by b, where b is your coefficient of x. Therefore, the coefficient of x is pi. So I have 2 pi divided by pi, which equals 2. Cool so far? Those are in your notes. I did separate videos on them. We should be OK for those at least 2 points. For next one is we talked about our x scale, or what I really always did is x scale or critical points. A lot of times I wrote up there. And because remember, there's 4 critical points on a period of our sine and our cosine graph. So to find the distance between those critical points, we used our x scale, which remember, all you had to do is take your period and divide it by 4. So it's just going to be 1/2. Well, remember, our period doesn't have pi, though, anymore. The period got our pi's divided out. So I'm just left with 2, and then x scale is 1/2. Then, remember, when graphing, what we did is we usually start with what we called an initial period. All right, because remember, these graphs go on forever in both directions. But we want to graph an initial period. And our initial period started at 0 and ended at 2 pi. The x value started at 0, ended at 2 pi. So we want to determine, is there going to be a new start and an end of our initial period? So to do that, we said the x value equaled 0. Well, now, that was for our parent graph. So what we're going to do is we're going to take whatever's inside our function. That's going to affect our start and our end. So I'm going to set that, whatever's inside of our function, equal to 0 and equal to 2 pi. So we want to see, is this going to have any effect on our start and our end of our graph? And the starting point, it doesn't. As I solve for x, x equals 0. On our end, it does affect our end point. Rather than ending our first period at 2 pi, we're now going to end our first period at 2. So what we're going to do is let's graph this to see what's going to happen. So what I like to do is kind of make my mark in the middle with my 0, or with my start, which is, in this case, is going to be x equals 0, which, as we know from graphing, is the y-intercept, or in this case, the y-intercept. OK, so then we have our x scale means 1/2 from each other. So we go 1, 2, 3, 4. So we have 1/2, 1, 3/2, and then 2. We can also go in the negative direction. No, because remember, our period is 2. When I did 2 pi divided by pi, I don't have a pi. Pi is not a part of my scale anymore. All right. So then now we just go ahead and graph. My amplitude is 1. So that means I'm going to go up to 1 and down to -1. And so graphing the sine function, if you guys remember, you start at 0, goes up to 1, back down, comes back up. So this is the sine graph. We're not trying to graph the sine graph, but we're going to use this graph as an aid to help us graph the cosecant graph. All right? So it's important for you guys to understand how to do this. That's why we did that whole homework assignment over and over and over, graphing all these. However, now we're not trying to graph sine, though. We're trying to graph 1 over sine of x. So here's what I want you guys to think about. Let's look at the x value of 1. So when x equals 1, what does the y value equal? When x equals 1, what does the y equal? 0, right? What about at -1? What is the y value? 0. So let's plug that in. So that means sine of x, sine of pi over x, when x equals 1, now equals 0. And when x equals -1 equals 0, right? Well, so that means in my equation for cosecant of x, that's 1 over 0. Can you have 1 divided by 0? No. That's going to be a undefined value. So therefore, what happens at undefined values, if you remember our rational functions, that's going to create asymptotes. So what you're going to do, every value that your function equals 0, you're going to create a vertical asymptote. Because that means that your function will be undefined at those values. So if you guys just want the simple directions, find all the x-intercepts and create vertical asymptotes.
On every single graph? Or is it just for certain graphs?
When graphing the cosecant and secants. OK?
Oh, well.
Wait, hold up. So, that's it in there.
OK. So remember, asymptotes, Nico, asymptotes are going to be what our function approaches, right? So we need to have our graph going to approach this. Now, in the videos that I showed for cosecant and secant, I actually did a table where you guys can see how that worked. But if we just kind of looked at it, what we'll notice is that our cosecant graph also shares the same values as our sine graph at our maximum and our minimum. So therefore, this graph is now going to kind of go in a parabola shape to approach towards the asymptotes. So this one's going to approach this asymptote, which is at the y-end. So then, if you just want simple directions, you find the max and the min. You find the max and the min of each one. And you have your approaching, you put kind of like a parabola-shaped graph approaching your asymptotes. Then to finalize the cosecant graph, we don't need the sine graph anymore. We've now used it to help us graph that, so we can now erase it. And there we go. There's my graph. Any questions on this? ¿Lo preguntas?